Hi, and welcome to In Search of Insight, Nootropics Depot's monthly podcast. I'm your host, Erika, and standing across from me is our product specialist, Emiel.
Hey, everyone.
You may know us by our other names. My name on Reddit is NootropicsDepotGuru, and Emiel is...
Pretty chill.
So if you are familiar with the In Search of Insight podcast, if you follow us on Reddit, that's r/NootropicsDepot, you already know the topic of today's podcast. We are talking about glutathione, all things glutathione. But before we get into the podcast details, we just wanted to say thanks so much for listening to last month's episode on mindfulness and bioassaying.
Yeah, that was a really good episode, and we got a lot of good responses, a lot of good questions, and we were able to talk about a lot of different topics that we normally wouldn't talk about.
Absolutely. Thanks so much for asking so many interesting questions, both about mindfulness, about supplementation in general, and about your personal experiences with cycling supplements, talking about caffeine, and just ways that supplements can help you optimize your physical and mental health in this new year. So if you haven't heard that podcast episode, we highly recommend checking it out. It's going to be available on our YouTube channel as well as all of our other streaming platforms, which include Spotify, Soundcloud, Google Podcast, and Apple Podcast as well. So now that we're about to jump into today's topic, we also wanted to remind you that if you ever have a question for us in general about supplements or about Nootropics Depot, you can make a post on Reddit. Our subreddit is r/NootropicsDepot. You can post your questions there, and on our subreddit, we also announce the next month's podcast topic ahead of time so that you can ask questions that we include in each podcast episode.
And they really help steer the direction of the podcast, so we're very appreciative of those questions, and they oftentimes allow me to research some different areas that I wouldn't have come up with myself.
Absolutely. So keep asking us questions, keep interacting, and keeping the conversation going on our subreddit. And now is our perfect segue into this month's topic for the In Search of Insight podcast. We are talking about all things glutathione. So we're going to be talking about glutathione synthesis, pathways, glutathione effects, and synergistic compounds that you can combine with glutathione, as well as different ways to increase glutathione within the body through supplementation. So together throughout the podcast today, we're going to develop a working understanding of what glutathione is and what it's doing in the body. So the first question I have for you, Emiel, is what is glutathione?
That's an important starting point. So for this episode, actually, we're going to have some visual aids up on the screen if you're following along on YouTube. So if you are looking at the screen right now and you kind of know a little bit about peptides, then you might realize that you're looking at a tripeptide. And glutathione is a tripeptide, which means that it is composed of 3 different amino acids. Those amino acids are cysteine, glutamate, and glycine. So when those all get together, you have glutathione. So with that in mind, let's actually take a look maybe at the synthesis pathway. So that's the next image that will flash up on the screen. So let's take a look at that. At the start of this process, you see that you have glutamate and cysteine, and there's an enzyme that joins these together with the first peptide link. So this enzyme is called gamma-glutamyl-cysteine synthase, and that produces it's a dipeptide at this point then, a dipeptide that is composed of glutamate and cysteine. Then there's another enzyme called glutathione synthetase, which is what produces the link between glycine and then gamma-glutamyl-cysteine that we generated in the previous step. And once all of those are bound together, then we have glutathione. And this is how glutathione is produced. So clearly it is very important to have a lot of L-cysteine around, glutamate around, and glycine around, because without those amino acids, you can't actually synthesize glutathione. So those are essential for the glutathione process here, and we'll touch on that a little bit later.
I'm also seeing ATP and ADP in the beginning of this process, and we discussed the functions of ATP a little bit in our very first podcast episode of In Search of Insight. That's the tart cherry episode. So the more that I learn and the more that I look at these visual aids, the more I can see how it's all connected. So let's dive a little bit deeper into how to increase glutathione levels in the body now that we understand how glutathione is actually made, coming together these 3 separate parts to create this tripeptide.
So once we have this tripeptide, it gets in every cell of the body pretty much, and in very high concentrations. So in millimolar concentrations, which that might not seem like a lot, but inside of cells, that is an extremely large concentration. And pretty much in every cell of the body, we see this concentration of glutathione. This clearly indicates that glutathione is very, very important to the overall functioning of our body. And every process, similar to ATP, like Erika was talking about, ATP is necessary for pretty much every single process in the body. Glutathione is at a similar level where wherever there is oxidation happening in the body, we need some amount of glutathione. And this is especially important in areas of the body that experience a lot of oxidation, like the lungs, the liver, and the brain. So this is where we see really high stores of glutathione, and it's important to keep those stores up.
In addition to these areas in the body, I also imagine that glutathione is highly present in skin, because our skin experiences a lot of oxidation when exposed to sunlight and UVB rays specifically.
Absolutely. Glutathione is also a very important mediator of skin health, and part of this is through its oxidation regulating effect. So besides its antioxidant effect, which we've established is one of the main things that's going on, and actually, to put this into perspective, let's talk about this antioxidant effect a little bit more, because antioxidant is such a general word and it can really encompass a lot of different processes. It can encompass a lot of different enzymes, but we are specifically concerned about glutathione here. So let's look at some of the enzymes that are involved with glutathione and its antioxidant effect. Up on your screen now, if you're looking or if you're listening to this on YouTube, then you'll see an image where we're looking at one of the primary ways in which glutathione gets rid of hydrogen peroxide. If you look at the left-hand corner, we see something marked as GPX, and this stands for glutathione peroxidase. And glutathione peroxidase, by using reduced glutathione, then can reduce hydrogen peroxide into basically water, which is safe and doesn't have an oxidative effect. So this is one of the ways in which glutathione has a direct antioxidant effect. It basically is fuel for glutathione peroxidase to then break down hydrogen peroxide. And because hydrogen peroxide is one of the main and oxidative compounds in our body, this is a great effect and makes sense why there is so much glutathione in all of our cells. That being said, since glutathione is not the only antioxidant, it doesn't really make sense that this somewhat simple and minor antioxidant effect overall is why glutathione is present in every single cell.
So if the antioxidant effect of glutathione on hydrogen peroxide is relatively minor compared to its overall...
Well, it's not relatively minor. So hydrogen peroxide, being one of the main oxidative compounds throughout our body, produces an enormous amount of oxidative stress. So it's important for glutathione to be present. But there are other things that can take care of hydrogen peroxide. So that indicates to me there should probably be another mechanism by which glutathione is so important for overall bodily function.
Okay, that makes sense. So then what is the other function of glutathione in terms of oxidation, or what are the other multiple ways that glutathione handles oxidation within the body?
For this, we kind of have to go back to the start and remember what glutathione is actually made of. So it's made of glycine, glutamate, and cysteine. And as some of you might already know, glutamate is also a very important excitatory neurotransmitter. And there is a theory that because there's such large concentrations of glutathione in pretty much every cell of the body, that glutathione might be a biological pool for glutamate. So basically, when we need some extra glutamate, then there's an enzyme called gamma-glutamyl transferase, which actually can liberate a glutamate from glutathione. And to visualize this, we're flashing up another image on the screen now. If you look on the left-hand side, you see where this enzyme gamma-glutamyl transferase comes in and cleaves off a glutamate from glutathione. So then we have free glutamate, and then we have cystenyl glycine that goes off into other processes, which also has some interesting effects that we can maybe talk about later. But the most important thing here is that when we need some glutamate to drive glutamatergic processes, then we can pull glutamate from glutathione. And because glutathione is already present in pretty much every cell, neuron and all of that, it means we basically have a very accessible pool of glutamate pretty much available to us at any point that we need it.
So I'm curious what those glutaminergic, that's the word you use, glutaminergic processes would be, just as an example.
For example, memory. So one of the ways by which memory works is LTP, long-term potentiation. And long-term potentiation, it's a pretty complex process, but the gist of it is basically that glutamate binds to NMDA receptors, and this enhanced NMDA functionality is what causes neuroplasticity specific to encoding memories. And this process is called long-term potentiation.
Oh, that's super important. Okay, so glutamate for memory and long-term potentiation. Are there any other really big, important kind of systems that glutamate is a part of? I'm just super curious about this part of glutathione.
It's pretty much a part of everything. So overall cellular function, neurological function, it constantly needs glutamate, but the right amount of glutamate. Because if we have too much glutamate, then we actually have issues with things like excitotoxicity, where cells get activated to such a large degree that they actually end up damaging themselves. Much like if I were to turn up my speaker system too loud and I end up blowing out a cone, a similar thing can happen to your cells, which is why we actually have glutamate that's always being contrasted by GABA, which is the main inhibitory neurotransmitter.
That was going to be my next question, is does extra excitatory compounds within the cell, does that cause oxidation? But now that you brought up GABA and the fact that GABA is balancing out glutamate, so the excitatory versus the inhibitory neurotransmitters, there's a bit of a balance there.
Yeah, and like you're saying, enhanced cellular activity because of something like glutamate would indeed cause oxidation, and that is part of the mechanism by which glutamate can have an excitotoxic effect.
Oh, I see.
That's one of the main drivers.
Okay, so glutamate having an excitotoxic effect, then we're kind of going back and linking to glutathione, because glutathione is an antioxidant.
Glutathione is an antioxidant, but more interestingly, glutamate is important for glutathione synthesis, which means that a glutamate will get used up and locked away, and it can't perform its actions like glutamate because it's now part of glutathione. So this storage pool works both ways. It can both deliver glutamate when it's necessary, and it can take away glutamate when there's too much glutamate.
So glutathione giveth and glutathione taketh away.
Absolutely.
Okay.
And this seems to be one of the most important functions of glutathione, is it seems to form synaptic transmissions of glutamate, and it really seems to be a somewhat of a master regulator of that process, both providing and taking away glutamate at specific points in time when that is necessary.
That's fascinating, and now I feel like I have a much better understanding of glutathione's function in the body, and the fact that it's in every single cell makes it seem like a really important compound to have in the human body, right?
Absolutely. Yeah, you definitely want large amounts of glutathione, especially because there's a lot of environmental factors and, things that we do, like drinking alcohol, that decrease glutathione levels. It's important to top those glutathione levels up. And, especially if you drink alcohol, it is a very good thing to keep in mind, because glutathione synthesis is slowed down by ethanol. So this is one of the reasons why glutathione and alcohol and hangovers and that whole conversation often happen together. It's all because of glutathione here.
Oh, that makes sense. So if my glutathione levels are low, or if I like to have, my nice glasses and bottles of wine here and there, I would obviously want to increase my levels of glutathione in my body, right?
Absolutely.
So how would I do that? What's the best way to increase glutathione levels in the body?
The easiest way is literally just to take glutathione, specifically reduce glutathione. So we haven't really talked about the two different forms of glutathione. So you have reduced glutathione, which is oftentimes abbreviated as GSH. And then you also have oxidized glutathione, which is oftentimes abbreviated to GSSG. And GSSG is basically just two glutathione molecules bound together through a sulfur bridge. And oxidized glutathione, so GSSG, actually has some of the opposite effects of reduced glutathione. So one of the main points in enhancing reduced glutathione status is also that you balance the ratio of reduced glutathione to oxidized glutathione.
And would oxidized glutathione be like glutathione that's already been used to manage or work on an oxidative stress event or within a cell that's experiencing oxidation?
Yes, actually, so this is probably something we should have touched on with the glutathione peroxidase segment. When glutathione performs its antioxidant function, it actually produces GSSG.
Okay, so it changes from glutathione, reduced glutathione, to the oxidated glutathione.
Correct. And this is actually a way in which you can look at how much oxidation is happening in someone's body. Basically, if you look at the GSH to GSSG ratio, and GSSG is much higher than GSH, then that probably means there were major oxidative stress events and we needed to burn through a lot of GSH, and through this process, regenerated a bunch of GSSG.
How would you determine the amount of GSSG? I'm curious. What would you use as like your marker?
You use GSSG as your marker.
Okay.
So from blood.
Oh, I see. Okay, gotcha. So you're just measuring for that specific compound within the blood.
Well, you're measuring for GSSG and you are measuring for GSG,
so that
GSH, so reduced glutathione and oxidized glutathione. And then you basically look at the ratio between reduced glutathione and oxidized glutathione. So if we have more oxidized glutathione than reduced glutathione, it means we are probably in a state of oxidation.
That makes sense.
The interesting thing is when GSSG is generated, we can actually go backwards to and regenerate more reduced glutathione. So this is happening through an enzyme called glutathione reductase. And we'll touch on that a little bit later. But there's basically always a cycle going on where reduced glutathione is being turned into oxidized glutathione, and through this process, it is having an antioxidant effect. And then we need to get rid of the oxidized glutathione. And this is also one of the reasons why we actually want to top up our reduced glutathione stores.
And this brings us back into what we were talking about with increasing levels of glutathione in the body.
Yes, so you can literally just take reduced glutathione. You can take it orally. There's been a lot of debate about whether or not reduced glutathione will actually enhance your glutathione status. And it will, but not all of it absorbs as reduced glutathione.
For those of you who are frequenters on Reddit or who are reading our blog or on Nootropics Depot's website a lot, you may be familiar with some of the bioavailability issues or concerns with glutathione. So I think this is a really interesting part of our conversation.
Absolutely. So while reduced glutathione, if let's say you take 500 milligrams or 1,000 milligrams, only a small portion will absorb as reduced glutathione. But some of it will, and some of it will absorb straight into the bloodstream as intact reduced glutathione, which means that within the bloodstream, it can already have an antioxidant effect, which is great. But because reduced glutathione is a peptide, it is sensitive to hydrolysis because those peptide bonds are not very strong, so those peptide bonds can easily be broken, whether that is in your stomach or once it is in circulation already, it can get broken down.
I'll ask the question that some of you might be wondering, which is, can you remind me, what is hydrolysis?
Great question. So as the name hydrolysis might indicate already, what do you think is one of the main drivers of this process?
Hydrogen.
Or?
Water.
Yeah. So basically, during hydrolysis, one molecule of H2O goes in and breaks the peptide bond. So that's basically what's happening.
Oh, that makes sense why hydrolysis would be causing that break of the peptide within your stomach, because when you're drinking water or just the water that's naturally present in your stomach interacts with the glutathione peptide, then it's going to cause this hydrolysis break.
Yes, and hydrolysis reactions are oftentimes also pH dependent, so because of the low pH of your stomach, this can speed up the hydrolysis of peptide bonds.
Ooh, okay. I like this direction that we're going in.
So some of the glutathione will be absorbed as straight up reduced glutathione. some of it in the stomach or in the intestines will break into its specific amino acids. So when we take a large amount of reduced glutathione, we then might get a bunch of L-cysteine that breaks off, a bunch of glutamate that breaks off, and a bunch of glycine that breaks off. And because L-cysteine and glycine and glutamate are all needed for reduced glutathione synthesis, it means that they can recombine in the body and create glutathione.
So the fact that glutathione isn't maybe as bioavailable, like to be absorbed into the bloodstream as some other compounds, isn't necessarily a concern, actually, because if you're supplementing with glutathione and some of it is being absorbed into the bloodstream, but then others of it are being broken into the 3 different amino acids that actually help synthesize glutathione within the body, you are getting benefits from the glutathione that's not being absorbed into the bloodstream. It's just not happening like immediately.
Correct. And some of it is happening immediately because not all of the glutathione will be hydrolyzed, which is one of the reasons why taking a higher dose is beneficial, because it's much easier to hydrolyze 10 milligrams of reduced glutathione than it is to hydrolyze 1,000 milligrams of reduced glutathione. It will take a little bit longer, which also means that potentially more intact reduced glutathione can actually absorb.
Okay, so here's a curveball that I know might be a total tangent, but that's okay. So now I want to know, because I'm thinking about the fact that I take powders and capsules, is there a benefit to taking glutathione in powder form because it might be absorbed faster? And then, oh wait, actually it's the opposite way. So is there a benefit to taking glutathione in a capsule or a tablet form because it might actually be absorbed slower in the stomach or broken down slower, and the powder is absorbed faster, so there'll be more hydrolysis? Am I totally off the map right now?
A little bit. If we did an enteric coating on glutathione, then you might bypass the stomach, and then you might have different absorption parameters. But a capsule dissolves very quickly. If you ever want to test this out, just throw a capsule in some acidic water and it will break down pretty quick. Especially in our stomach where we have a lot of agitation and it's warm and it's very acidic, those capsules will break down very quickly and then instantly release all of its content into the stomach, and then you just have glutathione there.
Okay, so the bioavailability question doesn't really... It's not so relevant to capsules versus powder. It's more just relevant to glutathione supplements in general.
Well, actually, now I'm thinking we just released some glutathione tablets, not capsules. And because tablets are usually quite hard pressed, they take a little bit longer than a capsule to completely disintegrate. So that actually might slow down the dissolution of glutathione into the stomach, and potentially that could have a positive effect. I'm not entirely sure. We'll have to do some more research. So one other method that is employed, and I couldn't really see myself doing it because glutathione is actually a little bit sour, but you could potentially take it sublingually too. So putting it in your mouth, maybe a smaller concentration, 50 milligrams or something, because we actually can't absorb a whole lot of material sublingually, but we might be able to get a small amount of absorption of glutathione to happen sublingually. There actually is a study where they tried 100 milligrams sublingual glutathione on participants, and it did seem to work. So this is a route we could go down.
Okay, so we have the powder that we can drink, like combined with water. We have the tablets that you can take, with any kind of liquid when you're swallowing the tablets. And then you have the potential benefits of the sublingual dosing, which may or may not result in better absorption.
Yes, and for sublingual use, the powder formulation would obviously be the easiest. So you just measure out your dose on one of our scales or another accurate scale, and then just put it under your tongue and probably leave it there for 5 to 10 minutes. However, because glutathione is a little bit acidic, I personally wouldn't necessarily try this because I have tried sublingual using acidic compounds sublingually, and it can make the sublingual membrane a little bit raw for me, and I don't like that feeling.
Okay, gotcha.
So with that in mind, the way I circumvent some of these problems, and I take reduced glutathione every day, I just take a higher dose. I take 1,000 milligrams a day. I have a feeling that a significant portion of that is being absorbed as reduced glutathione into my bloodstream. And then I just have all of the precursors for reduced glutathione synthesis. And this brings us to another really important topic that we're going to have to discuss at some point in this podcast, is that N-Acetylcysteine is one of the most popular ways in which to enhance glutathione levels. And part of the way in which N-Acetylcysteine does this is by acting as a prodrug for cysteine, L-cysteine, which, as we are all now somewhat intimately familiar with, L-cysteine is one of the major components. It's 1/3 of glutathione, so we need quite a lot of it. In fact, L-cysteine is one of the rate-limiting steps in glutathione synthesis. So if we go back to that initial image, and maybe we can flash it up on the screen again, so we have a bit of a visual guide here. But as you can see, first step in glutathione synthesis is combining glutamate and cysteine to make glutamylcysteine. And then later step in that process is where glycine combines. But in this first step, L-cysteine is the rate-limiting amino acid for glutathione synthesis because we always have an abundance of glutamate, so we don't have to worry about that. L-cysteine is the rate-limiting amino acid here. So one of the main ways in which we can enhance glutathione, reduce glutathione synthesis, is by increasing L-cysteine stores. And this is where N-acetylcysteine comes in, because it acts as a really good prodrug for L-cysteine, which can then deliver cysteine for glutathione synthesis. However, there is something a lot more interesting going on here. So there was a study in which they radio-labeled N-acetylcysteine. Radiolabeling is a process in which you attach a radioactive isotope to a compound, and then during fluorescence studies, it will glow selectively, and you can see if we gave someone N-acetylcysteine, where in their body did it go. And this particular study was a very elegant study because of its simplicity and how well it was executed. So basically what they did, they radiolabeled this N-acetylcysteine, and they thought if the N-acetylcysteine is radiolabeled, they knew if the N-acetylcysteine is radiolabeled, then the L-cysteine that N-acetylcysteine would produce through its prodrug action would also be radiolabeled, which then also means that the radiolabeled L-cysteine, which then goes into glutathione synthesis, would make radiolabeled glutathione. So you could pick this up on a fluorescence study.
Makes sense.
Makes sense, but quite this is like the most perfect research setup that you can imagine because you can trace how things are happening. The interesting thing that they found, though, is that most of the glutathione that they saw appear after administering a large amount of N-acetylcysteine was not radiolabeled, which means that N-acetylcysteine probably is not really acting as a prodrug for L-cysteine, which is really fascinating because this has been the status quo for however long N-acetylcysteine has been around.
Okay, so if it's not actually acting as the prodrug like we introduced, then what is N-acetyl-L-cysteine doing that causes more L-cysteine to be created within the body so that more glutathione can be created?
Yeah, so N-acetylcysteine has a really unique mechanism of action. It can actually thin mucus, and this is one of its main uses. It's to thin mucus out so it can be expelled easier. One of the main ways N-acetylcysteine does this is by breaking disulfide bonds of proteins, and mucus is made up of a matrix of glycoproteins. And usually that glycoprotein matrix is pretty loose, but if we get more and more disulfide bonds, then the glycoprotein matrix becomes stiffer and stiffer, and then that basically means we have less and less viscous mucus.
So to translate that into layperson's terms, your mucus goes from being nice and liquidy and fluid to being hard, clumpy, and crusty.
Correct. Well, hopefully not crusty within your body.
Oh, sure. Well,
when
you know
it's
what I
outside
mean.
of your body and it crusts up, yes. But inside of your body, those glycoprotein matrices become tighter and tighter, and then the mucus becomes less viscous, which makes it a lot harder to transport the mucus. So we want very viscous mucus so we can transport it. Now, this is where things get interesting. During this disulfide bond breaking, a lot of these proteins contain thiols like L-cysteine. So a really big store of L-cysteine is within proteins and mucous membranes and things like that. And when N-acetylcysteine goes in, it breaks those disulfide bonds and basically liberates massive quantities of L-cysteine.
Okay, so L-cysteine is actually important to have within our mucus because it's doing things within the body, and glutathione is coming in and saying, L-cysteine, be free to go do the other things that you need to.
Sort of, yeah. So that seems to be what's going on. So not just mucus, but other different proteins. And actually, in our bloodstream, we have a lot of albumin. Albumin is one of the most expressed proteins in our body. And specifically within our bloodstream, we have a albumin called cis-34 albumin, which is a cysteine-rich albumin, which means that when N-acetylcysteine gets into the bloodstream and it interacts with this cis-34 albumin, then it can liberate quite large concentrations of L-cysteine from that albumin. And then that L-cysteine can go into glutathione synthesis. So N-acetylcysteine doesn't seem to be acting as a prodrug for L-cysteine. It seems to work as a liberator of L-cysteine from protein sources, which is fascinating.
Okay, gotcha. So I was a little confused there by bringing glutathione back into the conversation, but the point is that by supplementing N-acetyl-L-cysteine, you are allowing more of that liberation of those proteins to happen, which then in turn would allow cysteine to become a part of that tripeptide of glutathione eventually as that synthesis is happening.
Well, because L-cysteine is the rate-limiting step or compound in glutathione synthesis, it basically means that without an adequate concentration of L-cysteine, we cannot make glutathione. And because it is rate-limiting, it means you can increase the rate of glutathione synthesis by increasing L-cysteine levels. So that is one of the main uses for N-acetylcysteine. And it was always thought that N-acetylcysteine is such a great inducer of glutathione synthesis because it itself is acting as a prodrug for L-cysteine. So, and the way it does this, and this really does work, and a small concentration of the L-cysteine comes from this, there's an enzyme called acylase 1, which basically deacetylates N-acetylcysteine, and then we have L-cysteine. And then that L-cysteine can go into glutathione synthesis. But this study then found that that doesn't seem to be the main pathway. The main pathway seems to be that N-acetylcysteine is, through its disulfide breaking bond activity, liberating massive quantities of L-cysteine from stores of L-cysteine, which happen to be proteins that N-acetylcysteine can break.
Okay, that makes so much sense then why N-acetyl-L-cysteine has been a really popular topic of conversation because of recent current world events that we're not allowed to say specifically on this podcast, but you're all very smart and understand what's going on in the world at large. So let's keep the conversation going and talking about N-acetyl-L-cysteine and what is happening further down the line in this process now that we understand the ways that it's working, not directly to increase glutathione synthesis, but indirectly by liberating these proteins that are required for the synthesis of glutathione.
Yeah, so liberating L-cysteine from the proteins.
Yeah, okay.
Through its disulfide bond breaking activity.
Okay, that was the one piece that I was missing. So L-cysteine is being liberated from proteins.
Yes.
Okay.
Because what are proteins?
Amino acids?
And if we go up the line a little bit more, amino acids turn into?
Ooh, you got me there.
When two amino acids link together.
Oh, peptides! Got
Yes.
it! Okay, cool. Gotcha.
And when multiple peptides link together.
We have dipeptides, tripeptides, quadrupeptides.
Not entirely. So
Okay.
the di, tri, quattro.
Oh, I see. So when peptides come together, they make proteins?
Yes. And the that thing, it's really simple. It just indicates how many amino acids are in the peptide.
Okay,
So
gotcha.
a dipeptide would be produced of how many amino acids?
2.
And a tripeptide?
3.
Which is what we're talking about now. Because
Gotcha.
the whole topic of conversation here is a tripeptide.
Right.
But longer peptide chains, they can chain together and they can fold, and then we get proteins.
Okay, that makes sense.
And then when proteins degrade, then we can liberate peptides again, and when those peptides degrade, we can liberate amino acids again. And actually, on this topic, since this is actually pretty relevant here, protein is one of our main sources of amino acids. And protein is one of our main sources of L-cysteine. So what do you think enhanced protein consumption would do?
That would enhance glutathione levels in the body, right?
Yes, because it is providing that essential L-cysteine. It's also providing that essential glutamate and glycine.
Oh, cool.
So protein is very important for overall glutathione synthesis as well.
Okay, so now I'm thinking, just to connect it to all of you who are listening, for people who are eating a vegetarian or a vegan diet, they might want to consider increasing their glutathione levels.
Yeah, so if you are a vegetarian or a vegan and you know that your protein consumption is maybe a little bit low, then there is a good possibility that your glutathione synthesis is a little bit lower. So it would probably be quite beneficial to take some reduced glutathione, for example.
Besides being a liberator for L-cysteine, are there any other effects of N-Acetyl-L-cysteine in the body?
Yeah, so N-Acetyl-L-cysteine has a lot of different effects throughout the body, but let's keep the focus more on glutathione. So one really interesting aspect of N-Acetylcysteine and just L-cysteine in general, and also glutathione itself. So for anyone that already is taking glutathione and has taken it as a powder, one thing you might notice is that it is slightly sulfurous. And this is due to the L-cysteine content. And in the context of N-acetylcysteine, that L-cysteine, part of it is being turned into glutathione, but part of it is actually being turned into hydrogen sulfide, which you might know as the smell of sewers, rotten eggs, things like that. Seems highly unpleasant, but interestingly enough, hydrogen sulfide is what we call a gasotransmitter, so a gaseous neurotransmitter. And there's a few of those. Well, not a whole lot. There's 3 of those that we currently know of. One of them is nitric oxide, one of them is carbon monoxide, and the last one is hydrogen sulfide. So it acts like a neurotransmitter. But one of the interesting things about hydrogen sulfide is it also helps transport L-cysteine. And specifically, it helps transport L-cysteine to where glutathione synthesis happens. And after glutathione is produced, hydrogen sulfide actually helps partition glutathione into the mitochondria of the cell, which is kind of where we want glutathione to be anyways.
So hydrogen sulfide is a super important part in the process of this glutathione synthesis and then glutathione being used in the cells.
It's not necessarily a really important aspect of general glutathione function throughout the body, but in the context of N-acetylcysteine, it's very important, since N-acetylcysteine is generating quite large concentrations of hydrogen sulfide, in addition to generating high amounts of L-cysteine. So this is maybe one of the reasons why N-acetylcysteine is so effective at enhancing glutathione status. It's because it itself is acting as a prodrug for L-cysteine. It is liberating, through its disulfide breaking bond activity, L-cysteine from proteins, and it is getting that generated L-cysteine to where it needs to be for glutathione synthesis, and as the cherry on top, it transports glutathione to where it needs to be, to the mitochondria. So this is a really interesting aspect of N-acetylcysteine in my opinion, and hydrogen sulfide is a big player here. But it's not the only thing that can be a hydrogen sulfide donor, and we have a few other things that we can rely on for that as well.
What are those things?
So one of those things actually might be taurine. So taurine is actually produced from L-cysteine and is one of the only other amino acids that has a sulfur group. And taurine itself seems to be able to enhance, or not enhance, but act as a hydrogen sulfide donor. So by taking taurine, we might actually see enhancement in glutathione synthesis and utilization.
Oh, that's fascinating. Is taurine also an endogenous compound in the body, or is that only something that we have to take from outside sources?
No, taurine is also an endogenous amino acid, and it actually works as a neurotransmitter as well.
Oh, wow, that's fascinating. So glutathione, taurine, and cysteine are all endogenous, which means that they're all present in our bodies at all times.
Yes.
Okay, cool.
And we can obviously get them from exogenous sources too, and then we can enhance their activity and get more of those benefits from those compounds.
Awesome.
Another thing to consider here is actually if we talk about garlic. So a lot of people want to supplement garlic because of its health benefits, and indeed garlic has a lot of health benefits. And part of these health benefits are that it enhances glutathione synthesis and glutathione status generally. I was always curious how this worked though, and I recently found out that allicin gets broken down into a few different compounds. One of them is diallyl trisulfide. And diallyl trisulfide, when it interacts with reduced glutathione, very rapidly generates hydrogen sulfide. So this is likely one of the ways in which it is enhancing glutathione synthesis and then actually getting a lot of those neurological benefits of hydrogen sulfide, because it does have some very important neurological functions, like enhancing LTP, similarly to perhaps glutathione and glutamate and that link.
Okay, so long-term potentiation.
Yes.
Gotcha. Remembering that.
And hydrogen sulfide seems to be an important player here too, and it seems that reduced glutathione is also an important player in generating hydrogen sulfide. So getting more or a higher reduced glutathione status and then eating potentially just garlic in our diet could be generating hydrogen sulfide within our body, which helps enhance glutathione synthesis and then also acts as a neurotransmitter.
Wow, this is incredible. Okay, so now we have a couple of different compounds and foods and ideas of things that could be combined synergistically with glutathione that would help increase glutathione levels in the body.
Yeah. So, and there's a few other things that can actually do this. So there's a few different enzymes that we can influence, and there's a few different herbs and different supplements that can affect glutathione status. One of these actually is glycine. So glycine is, again, a third of glutathione. So enhancing glycine levels could also enhance glutathione synthesis. And in fact, a recent study indicated that not only is L-cysteine a rate-limiting step in glutathione synthesis, so is glycine, which and we'll flash it up again, if we look at the first image we looked at, you can see that after we have made glutamylcysteine, the next step is attaching glycine to glutamylcysteine. So, and this is further upstream in the process too, further downstream in the process. So we can imagine that glycine definitely is a rate-limiting step here too, and there is research now backing that up. This means that supplementing with glycine is also a good strategy for enhancing glutathione synthesis. And let's not stop there, because we have a really good glycine source, magnesium glycinate, which actually contains a very large quantity of glycine. But magnesium also seems to be important for glutathione synthesis. So there was a recent study where they looked at animals who were deficient in magnesium. And in these magnesium deficient animals, they found a 2-fold decrease in glutathione status. So clearly magnesium is an important player here. So taking magnesium glycinate would then, 1, give you more magnesium, which should already enhance glutathione status, and 2, it provides glycine, which should enhance glutathione synthesis. So it's kind of a nice 2-pronged effect that we can get by taking magnesium glycinate. So this would be a great way to enhance glutathione synthesis, especially when taken alongside reduced glutathione.
Okay, cool. So we've got magnesium glycinate alongside glutathione. you briefly mentioned taurine, which could be something interesting to consider supplementing alongside glutathione.
For a hydrogen sulfide donor.
Right. We talked about garlic as a potential complementary food to eat or include in your diet to help the processes of glutathione in the body. What other compounds, supplements, or food might we want to combine with glutathione to increase levels of glutathione in the body?
Okay, I like this food idea, so let's keep going there. So we already have identified garlic as a potential donor for hydrogen sulfide, which can enhance glutathione synthesis. Another thing that we could look at actually is broccoli, or broccoli sprouts is even better, especially if we put a little bit of apparently dehydrated mustard seed powder on it. So
it's funny that some of these kind of stinky foods are working in a way to produce hydrogen sulfide because, garlic maybe causes a little bit more smell than you'd like, but that's probably the hydrogen sulfide, right?
Partially. And part of the other thing is with garlic, you just smell those sulfuric garlic compounds. So diallyl trisulfide, for example, very quickly turns into hydrogen sulfide, but on the other hand, diallyl disulfide doesn't. So, but those definitely have a smell to it, which you could probably excrete through your skin and that you can smell.
Yeah, and some people don't like the taste of broccoli, but more so because of the smell of broccoli rather than the taste. So I'm just thinking in terms of like foods and food experiences, it's interesting that these kind of strong tastes and smelling foods like garlic or broccoli are a part of what might help increase glutathione production within the body.
Yeah, and in the brassicas, so specifically here, of course, broccoli and broccoli sprouts, there is a sulfur-containing compound called sulforaphane, which a lot of you are probably quite familiar with because there is a lot of hype surrounding this compound, and for relatively good reason, actually. So one of the interesting things about sulforaphane is that it acts on a pathway called NRF2. And through this pathway, it can actually increase the synthesis of glutathione, and it can help regenerate GSSG, so oxidized glutathione, back into reduced glutathione by enhancing the enzyme glutathione reductase, which is what drives that reaction. So if you really want a comprehensive food idea for enhancing glutathione synthesis and status, you could combine garlic with broccoli or broccoli sprouts, and then within broccoli, sulforaphane exists as a different compound, and you need an enzyme to help break that down. And that enzyme apparently is highly present in dehydrated mustard powder. So put some dehydrated mustard powder on your broccoli and cook it with some garlic, and you might have a pretty good food source for glutathione production.
Interesting. And then because we're talking about brassicas, there's also other foods, right, that might include some of these similar compounds, like Brussels sprouts, or even, is cabbage a part of the brassicas family as well?
Yeah.
Okay, cool. So like red cabbage, which also has large amounts of anthocyanins, which is something that we talked about in our very first podcast episode, that tart cherry podcast. Mm-hmm. So that red color from cabbage has anthocyanins, but because it's part of the brassicas family, also has some of these beneficial compounds for glutathione production.
Yeah, this wouldn't surprise me, but I didn't look that far into the brassica family, so I'm not entirely sure if every single brassica family will contain these beneficial compounds.
You'll have to tell us on Reddit. For anyone who's a real Brassica fanboy, let us know if you've done any research on red cabbage or Napa cabbage, broccoli, or Brussels sprouts, and any of the other vegetables in the brassicas family that we might be leaving out.
Yes, this would be really interesting to look into. But back on the NRF2 topic, another thing that acts on NRF2 in a pretty significant way is alpha-lipoic acid. And it has been shown, in fact, that alpha-lipoic acid also helps enhance both glutathione synthesis and helps enhance glutathione reductase activity, which then helps generate reduced glutathione from oxidized glutathione. So alpha-lipoic acid would be another good thing to lean on for enhancing synthesis of glutathione and would be a good thing to take alongside reduced glutathione.
Now we're developing quite a robust dietary and supplemental stack idea for what you can pair alongside glutathione to help increase that glutathione synthesis within the body. But I'm curious, are there any other compounds or foods that can also have beneficial effects for this reason?
Yeah, there are actually quite a few. So another really interesting one that I found is silymarin from milk thistle. So we've been talking all this time about enhancing glutathione synthesis and making L-cysteine more bioavailable or available for this synthesis process. But what we haven't even touched on is how can we actually increase L-cysteine synthesis? And this is also possible. And silymarin from milk thistle specifically appears to enhance L-cysteine synthesis, which then makes more L-cysteine available for glutathione synthesis. And this might be one of the reasons why milk thistle is particularly hepatoprotective, because it is causing localized synthesis of L-cysteine, so where we want that L-cysteine to be already, so that when it is converted into glutathione, it's already where it needs to be, and we can have this very comprehensive oxidation regulating effect in the liver because silymarin likely is increasing L-cysteine synthesis.
Wow. So for those of you who are taking notes, add milk thistle to your list of things that might complement and work well alongside glutathione.
Yeah, that would be a really good one. Another good one, and we haven't actually touched on this aspect of glutathione yet. So glutathione definitely is the master antioxidant that takes care of hydrogen peroxide. That's a very important effect and why it's in pretty much every cell. Another important effect of glutathione is that it is one of the main ways in which the body detoxifies itself. So the way it does this is actually by attaching glutathione to xenobiotics. So xenobiotics just being exogenous things that are coming in that are normally not present in our body that can have toxic effects. So we want to get those out. And one of the ways this is done is by attaching glutathione to the xenobiotics. For this to happen though, we need an enzyme called glutathione S transferase. And actually as a visual aid, we will flash up an image of this happening now. So through this enzyme, glutathione S transferase, we can attach glutathione to the xenobiotic, and then we have a glutathione S conjugate with the offending xenobiotic, and then it's neutralized. So we call this detoxification. And there are certain plants that can actually enhance this glutathione S transferase activity, and one of those plants is ginkgo. And specifically within ginkgo bilobalide, one of the compounds that we specifically standardize for in our ginkgo extract, is the thing that enhances glutathione S transferase activity, meaning that by taking something like ginkgo biloba, you can enhance the activity of reduced glutathione and make it more effective at what it does, which is a really interesting effect.
Absolutely. What other supplements or compounds would be complementary alongside glutathione?
One other one would be curcumin. So curcumin actually enhances the activity of glutathione peroxidase, and as we talked about earlier, glutathione peroxidase is the enzyme that uses reduced glutathione as a fuel to then break down hydrogen peroxide. So that's one of the most important functions of glutathione. So enhancing glutathione peroxidase activity is very important to overall glutathione effectiveness within the body. So taking something like curcumin would be a very interesting strategy of helping to enhance this. And this might actually be where some of curcumin's antioxidant effects are coming from.
So I'm guessing that other antioxidant type supplements or foods would pair well with glutathione, right? Because we know that glutathione is doing a lot of work on oxidative stress events within the body, so it would only make sense to me, logically, that other antioxidant type foods or compounds would also help in that process.
Yeah, and maybe for a somewhat unexpected reason. So if we are utilizing other things, exogenous things from plants that we're consuming or from fruits that we are consuming that are combating H2O2, so hydrogen peroxide levels, then we need to actually burn through less reduced glutathione to reduce those levels, which also means we are generating less oxidized glutathione. And this is really good.
Absolutely. So are we nearing the end of the the helpful compounds or foods that might assist in glutathione production and glutathione activity, or is there still more?
No, I think that's it.
Okay.
There definitely are more, but we could keep on going and going. So maybe this is another thing we can talk about on Reddit. If any of you are curious, we can get a list of different things that we can get together to enhance glutathione activity, synthesis, status, all of those interesting things.
Absolutely. This is also probably the perfect time to introduce a new segment that we're going to be having in all future episodes of the In Search of Insight podcast. So, cue jingle. New product releases. This is a really exciting segment of the podcast because we're going to talk about the new products that have been released since the last podcast has been out. Our most recent podcast episode was released in January 2022, talking all about mindfulness and bioassaying. And since that podcast has been released, Nootropics Depot has also released a handful of new products, the first of which is reduced glutathione tablets, specifically relevant to this podcast that we're recording now.
And very convenient, because up until this point, we only had the powder, and powders don't always work all too well, especially when traveling.
Absolutely. Sometimes it's annoying to get your scale out and weigh your powder for your specific dose, so we wanted to make it a little bit easier for you to supplement glutathione in your day-to-day life, and that is why glutathione tablets might be a good choice for those of you who may be a little bit powder averse. The next new product that we have released in the last month is a sesame extract in capsule form. Emiel, can you tell us a little bit more about the sesame extract?
Yeah, so sesame is very high in a compound called sesamin, and actually is also working on NRF2. So that goes back to the alpha-lipoic acid thing we were talking about and the Brassicas sulforaphane connection. So you might get something similar with sesame, or sesamin specifically. Sesamin is also really interesting for enhancing cognitive health. It's quite neuroprotective and also has good liver protective effects and seems to really enhance metabolic health. So good to add to pretty much any stack.
Awesome. So the sesame extract comes in capsules. So again, for those of you who might be a little bit powder averse, this is really convenient. The next product that we've released is Syracuse 300 milligram capsules. Emiel, a little bit of background on Syracuse and why the 300 milligram capsule release is exciting at this point.
Syracuse is a patented extract of lemon balm. So we have two different lemon balms on the site. One of them is just our generic, and then this Syracuse one is much higher in rosmarinic acid and some of the other bioactives. However, in higher doses, something interesting happens with lemon balm. Instead of being calming and sleep-inducing and things like that, it can actually be a little bit stimulating. I first discovered this effect when I went on a plane ride somewhere, and I thought, hey, if I take a large dose of lemon balm, I will surely sleep. So I took 3 grams of lemon balm, which, by the way, is a little bit high.
That's a mega dose of what we would call a mega dose. Yeah.
This was back in the day when I was a little bit less risk averse, and these mega doses seemed like a good idea. The interesting thing I found, though, with this high dose of lemon balm, which was really inconvenient, is I could not sleep. I was up and awake, and I felt really good, but I was really hoping to sleep on this flight, and that didn't happen. A similar thing happens with Syracuse. So Syracuse just generally is going to be more uplifting and less calming than our generic lemon balm, just because of the higher content of rosmarinic acid and other bioactive. So, especially in the 600 milligram dose, some people were not getting the desired effects, and they were getting those desired effects with lower doses. So based on this, we decided to offer a 300 milligram dose that is geared more towards relaxation, and the 600 milligram dose can be more geared towards uplifting mood effects.
So now you have 2 options for your Syracuse supplements, one that is going to have these, potentially stimulating and uplifting, and then one that's half the dose, 300 milligrams, that you can take when you're looking for those more typical and traditional effects from a lemon balm supplement.
And I would say for people that are new to lemon balm, or not necessarily lemon balm, but new to Syracuse, and they want to try both a 300 and a 600 milligram dose, a very easy way to do this would be to get the 300 milligram capsules, try it at 300 milligrams, and then double your dose to 600. With the 600 milligram capsules, it's kind of hard to split them into two. So this is a better setup potentially to test out Syracuse for the first time.
And different dosage options for Syracuse.
Absolutely.
Super cool. So this is probably one of my most sought after and exciting personal supplement releases that Nootropics Depot has done in the last couple of months. And it is Sibelius Sage Capsules. Woo! I'm so excited about Sibelius Sage Capsules, primarily because I take Sibelius Sage every single day as a part of my daily powder stack. But I really do love the convenience of capsules, and I also like the option to take sage early in the day and then later in the day. And for me, reaching for a capsule is just a little bit faster and a little bit easier than measuring out the powder. And that means that I get the benefits that I really, really enjoy from Sibelius Sage with even more ease.
Nice. And what are your favorite effects with Sibelius Sage?
Sibelius Sage has this really amazing calming effect. It's slightly, it makes me feel like I have a little bit more physical energy, and just generally gives me a sense of calm and groundedness. So rather than energy coming from like a mental stimulation place, Sibelius Sage makes me feel like I have the physical energy to maybe do some yard work or like wash the dishes, things that might feel a little bit annoying or just a little bit like exhausting in my day-to-day. Sibelius Sage makes me feel like I can tackle those physical tasks with a lot of ease, and because it gives me that sense of calm as well, I feel less stressed and maybe a little bit less annoyed at those kind of daily household chores or those things on my to-do list that I might put off or procrastinate on.
Yeah, so a good thing to have conveniently available to dose whenever you need it.
Absolutely, because it already helps my motivation and just kind of my sense of what do I need to do today, and can I be in this present moment to go through these different tasks. So having it available easily and quickly in capsule form makes that process even more enjoyable for me. Now, our last release that we've made since our most recent podcast episode is Baikal Skullcap Extract tablets and powder. And Emiel, I'm sure you have some interesting and exciting things to say about this new extract that we've released.
Yeah, this was a really interesting one to develop because we had a lot of freedom in what bioactives we could use. So during the beta testing program that we have internally, it's not external at this point, we just do it internally within other people in the office or with some friends and family. During this beta testing phase, we found that the formulation that we went with gave a really nice blend of effects. So nice and calming, but also focus enhancing, which was really interesting and only happened in this iteration of the Baikal Skullcap extract. But it was interesting going through and trying different combinations of the bioactives in there. And those main bioactives in this current formulation are Baikalin, and Apigenin. We also played around with Waganin and Norwaganin a little bit and some other different flavonoids and flavones that are normally found in Baikal Skullcap. And the interesting thing is that every single iteration was completely different. And this was our favorite, and it was the favorite amongst a lot of different testers. So this is why this Baikal Skullcap extract is really interesting and exciting, because as far as we know, Baikal Skullcap has never really been done with this level of specificity, but it's very beneficial to do it with this level of specificity because we can tease out very specific effects. And we're very happy with the effect profile that we found. And similar to Erika with Sibelius Sage, I have similar effects actually with the Baikal Skullcap. So it helps calm me down while keeping me elevated and focused. So it's really good for me to do research work and writing work.
So to give you just a little recap of those new supplements that have been released, we have the reduced glutathione tablets, we have sesame capsules, we have Syracuse 300 milligram capsules, we have Sibelius Sage capsules, and we have Baikal Skullcap extract tablets and powder. So every month in this segment, we're going to talk about the new products that are being released and have been released since the last podcast. And there's another really exciting announcement that we're making today in this podcast, which is that we have some new Natrium stacks about to release very, very soon, which for those of you who are signed up to our newsletter, you would have gotten an email giving you some hints as to what these natrium stacks might be for you to guess. So I'll give you the hints now. The first hint for these new natrium products is that we have made a novel take on a legendary stack. What might that be? You can start thinking about these questions and let us know if you have an idea of what it is on Reddit. Also, this would be Aquaman's favorite stack. So those two hints are for the first natrium stack that we're releasing. So hint number 1, a novel take on a legendary stack, and then number 2, this would be Aquaman's favorite stack. Now for the second natrium product that we are going to be releasing, the first clue is, this one goes to 11. And the second clue is smooth stimulation.
Ooh.
So now you have those hints in mind for these new natrium stacks that we're going to be releasing very, very soon. We're curious to hear what your thoughts might be, what your predictions might be for what these products are. So let us know what you're thinking on Reddit. Feel free to add your guess in that thread. And if you want, you can tag Pretty Chill or Nootropics Depot Guru, and we'll chat with you on Reddit. We always love the interaction and the conversation that comes from interacting with you on Reddit. That's r/Nootropics Depot. So that concludes our new product release segment of the podcast. We're going to jump into my personal favorite part of the podcast, which is answering your questions, the questions that you submit in our monthly Q&A post on Reddit about this month's podcast topic. So the questions got really deep this month. You went into some really interesting directions and curiosities that have really helped us to do our research on glutathione and N-Acetylcysteine. So I'm going to ask the questions. Emiel is going to talk about the research that will help answer these questions, and we will go through all of your curiosities that you have posted on Reddit. The first question that we're going to discuss today is by CW1008, and this question is about mucus and membrane thinning. So the question is, does reduced glutathione have the same membrane thinning effects of NAC? I had to stop taking NAC as this was a major side effect, making it painful to even swallow. Yikes.
So that goes back to the disulfide breaking bond action of N-Acetylcysteine, so it can definitely thin those mucous membranes a little bit by breaking those disulfide bonds, while reduced glutathione has this to a much lower degree. It could, but I don't think this is a concern at all with reduced glutathione.
That's really good to know. So now moving on to our next question. In a similar topic, this question was asked by TTYYLL Gabagal. Sorry for butchering your username, but I'm really not sure how to pronounce it all in one go, so that's going to be it for today. So this person asks, is there any concern about stomach issues due to the thinning of mucus? Great question.
And again, this could be a concern, especially if you have some issues there already, and if you are taking very high amounts of N-Acetylcysteine because of that disulfide breaking bond effect. So there really is no way around that, and it seems to be very integral to the glutathione synthesis effects of N-Acetylcysteine. That being said, N-Acetylcysteine also appears to have some gastroprotective effects, and specifically hydrogen sulfide seems to have some gastroprotective effects, so you might want to take this with a grain of salt, but it is good to be aware of.
Absolutely. So now moving on to questions that focus on the mechanisms of action and the subjective effects of these two areas that we're talking about. Zidatris, who is a regular listener and asking awesome questions, thanks so much for your participation, asked, would taking NAC with something like, say, caffeine for the increase in dopamine be counterproductive or actually favorable?
If NAC itself actually enhanced dopamine levels, then this would be favorable, but that doesn't seem to be entirely the case. What does seem to be happening is that the hydrogen sulfide, by acting as a neurotransmitter, can influence dopamine synthesis and dopamine release. It might even be a monoamine oxidase B inhibitor, but this is not totally confirmed yet. So with this in mind, the hydrogen sulfide portion of it would probably go well with caffeine because it would enhance the effectiveness of caffeine. Because one of the ways by which caffeine works is by blocking adenosine receptors. But by blocking adenosine receptors, you basically open more activity for the dopaminergic receptors, because a lot of adenosine receptors form heterodimers with dopamine receptors. And basically, when the adenosine receptors are turned on, the adenosine receptor limits the activity of the dopaminergic neurons. So when you block adenosine, then the opposite happens and we get more dopaminergic activity. So if that's what's going on here a little bit too, and actually hydrogen sulfide seems to also block adenosine A2A receptors, although this is a little bit of a debatable topic still because there isn't a very strong link, but there seems to be a link there. So with that in mind, they probably would make a good pairing.
Good to know. So now, moving on to another question from Cupid Deloc 7. They ask, does NAC help with racing thoughts?
Potentially. I mean, again, this would likely be going through the hydrogen sulfide pathway. Although, now that I'm thinking about it, since glutathione has an effect on how glutamate works in the body, and acting as both a reserve for injecting glutamate where it is needed, but also taking away glutamate where it is not needed, it might be causing more cellular activation that we don't want. Maybe if the racing thoughts are related to excess glutamatergic activity, then maybe the glutathione portion of things could take care of that. Another interesting thing is, of course, the hydrogen sulfide link, because hydrogen sulfide works as a neurotransmitter, a gaseous neurotransmitter. And actually, I found an interesting study that was showing that hydrogen sulfide might even upregulate GABA B receptors. So with this in mind, it might have a calming effect and it might be beneficial for this topic.
Amazing. Another question that we got from Tuckers, that's with a 3 as the E, is thoughts on longer-term NAC and diminished pleasure from activities of life. It seems to modulate glutamatergic, neurotropic, and dopaminergic systems that have a little bit too much after prolonged use. Would reduced glutathione carry the same effect, or is it limited to the benefits of solely glutathione?
So, as we've been talking about, those glutamate effects seem to actually be related to glutathione itself. So those effects would extend to reduced glutathione as well. But since we already have a lot of reduced glutathione in our bodies and we're just kind of enhancing this activity, I'm not entirely sure if this is where the link lies. So it might not be due to glutamatergic functioning. It might be due to some of the other effects, maybe of hydrogen sulfide. But it's hard to know. And there doesn't seem to be any research on this. In fact, there seems to be a lot of research on the opposite end, where it is enhancing pleasure. So
to be determined.
To be determined.
Nice. Tuckers also asks, does reduced glutathione work as well as NAC for alleviating alcohol-induced damage? What about for reducing cravings?
So as far as I know, NAC shouldn't have an effect on cravings. It should just be enhancing the protective effects against alcohol through glutathione synthesis. Again, there might be a link with hydrogen sulfide here, where hydrogen sulfide might be in diminishing some of these cravings, but I personally have not delved into the research that deep yet for that. That might be where a link exists. In terms of glutathione versus N-Acetylcysteine for the alcohol-mediated effects, as we talked about earlier, ethanol decreases the synthesis of reduced glutathione, and this is one of the ways in which alcohol can have negative health outcomes. So with that in mind, reduced glutathione and NAC will both help enhance glutathione status, so they should both be beneficial.
Awesome. And that kind of leads us into our next question, which was asked by Swift Shop, which is, what's the deal with NAC and alcohol?
Yeah, exactly that. It helps enhance glutathione synthesis, and because glutathione is depleted by alcohol and because alcohol causes a lot of oxidation throughout the body, it's a good thing to have.
Awesome. So now we're going to move on to questions about prolonged use, antioxidant effects, and related systems in the body. So the first question was asked by Arjan. The first of a couple of questions in a series is, could NAC supplementation cause breakdown of the blood-brain barrier in humans? A few years ago, there was a lot of talk about this possibility based on this paper that they linked in the question on Reddit.
Yeah, it's just a single study. It doesn't seem to have been replicated since, and it obviously got a lot of hype. I'm not totally sure if this really is a thing, especially because NAC itself doesn't cross the blood-brain barrier. That being said, it could definitely still get to the blood-brain barrier and do something there. And given its sulfide bond-breaking activity, potentially it could cause some issues there. But I honestly don't think that there is a serious concern there for actually breaking down the blood-brain barrier, but something to keep in mind about N-Acetylcysteine and related compounds that might have an effect on the blood-brain barrier. But again, the blood-brain barrier is incredibly complex and has a lot of protective features to not allow things in. So I would be surprised that a naturally occurring compound, which is normally also naturally present in our body and we get from our diet as well, wouldn't necessarily be breaking down the blood-brain barrier. But stranger things have happened. So until we see more research, this is always a possibility. And I guess this is kind of how science works. There's a lot of unknowns, and until we have more research to prove this, more than just a single study that was highly hyped and never seemed to really go anywhere from there, no repeat studies, something to keep in mind that maybe this is not the best designed study, and maybe they were just adding enormous amounts of NAC straight to blood-brain barrier tissue, and then maybe the low pH of NAC in such a high concentration could cause the damage, not NAC itself.
Really interesting and a great question. So another segment of Arjan's question is, can antioxidant supplementation, like with NAC, actually cause reductive stress and thereby indirectly increase oxidative stress, as laid out here in another study that was linked?
This is always a concern with antioxidants, especially exogenous antioxidants that don't normally exist endogenously, and even endogenous antioxidants like vitamin C. Vitamin C in very high doses, and just normally too. Vitamin C, when it produces its antioxidant effects, similar to glutathione, then produces another compound that is a pro-oxidant. But there's other protective mechanisms that then take this pro-oxidative compound and take care of it. So similar to GSH, reduced glutathione, turning into GSSG, oxidized glutathione, and then glutathione reductase, taking that GSSG and regenerating reduced glutathione from that. A similar thing happens with vitamin C and other antioxidant molecules. However, once we start saturating these enzymes that convert those things back to the antioxidant compounds, then we might run into a situation where we have an overabundance of pro-oxidants with no antioxidants to balance them out. And this could be a direct result of taking too many antioxidants. But as far as I'm aware, you would really have to be going hard on a lot of different antioxidants. And I think this is another interesting aspect of glutathione, is that because it's so tightly regulated and because it is present in every cell of the body and because we need such large amounts of it, I see very little risk of pro-oxidant activity when taking reduced glutathione at normal levels, like 500 milligrams to 1,000 milligrams a day.
Awesome. Good to know. Chocobo Eater asks, NAC sometimes comes with molybdenum and selenium in the same capsule because it's thought to deplete those minerals. Does glutathione also deplete these minerals or anything else?
So NAC actually doesn't deplete those minerals at all. But that being said, both NAC and glutathione are both metal chelators, and they can chelate metals, and this is part of their beneficial effects. That being said, the reason why selenium is oftentimes included with NAC and even sometimes glutathione supplements is because selenium is an important cofactor for the various glutathione enzymes. So increasing your selenium status would indeed be an interesting thing for further enhancing glutathione status and synthesis and function. But it's not necessary, and I don't think that NAC or reduced glutathione actually deplete them. It's just that they are beneficial cofactors. And I actually had never heard about this, so I looked it up and I found the page from Natural Factors, I think, who make this product. They also seem to be the only people who make this product, but I might be missing a few, but in their description, they even say molybdenum and selenium are both important cofactors for the function of glutathione, and that's why they're included.
Really cool. Good to know. See, this is why we love you all asking us questions, because sometimes it leads us down pathways that we never would have found without your questions. So continuing, we have a question from the Optimizer, which is, are there any situations where it may be beneficial to take both N-Acetylcysteine and reduced glutathione at the same time? Can they be synergistic? And the resounding answer is yes.
And of course, this is because we would have multiple sources of L-cysteine, and we would have that hydrogen sulfide donor activity, which is then helping to shuttle L-cysteine around and further enhancing glutathione synthesis. So one way maybe to do it would be to rely on NAC for the initial increases in glutathione, because NAC does produce quicker effects overall, and then relying on reduced glutathione for long-term supplementation to top those levels up.
Awesome. The Optimizer also asks, other than cost, is there any advantage of NAC over consistent glutathione dosing?
Yeah, so cost is definitely an issue with reduced glutathione. It's quite expensive, especially in the doses that we need to take, and NAC is cheaper and more effective overall at enhancing glutathione synthesis. So that would be definitely a major plus for N-acetylcysteine. That being said, N-acetylcysteine also has a bunch of different effects, like the sulfide breaking bond activity, which definitely has a lot of effects that maybe you're not looking for. So that would be a plus for reduced glutathione, because reduced glutathione doesn't have those effects. Another effect that N-acetylcysteine has is the fact that it is a H2S hydrogen sulfide donor, and maybe you don't respond all too well to hydrogen sulfide donors and you don't want this, then reduced glutathione again would win, because it is a more direct way, maybe not the most efficient way, but it's a more direct way of enhancing glutathione synthesis. But with that in mind, if you combine glutathione with some of the reduced glutathione with some of the other supplements we talked about, like curcumin or ginkgo, or even taurine or milk thistle, then you can enhance the effectiveness of orally taken reduced glutathione. So there may be some scenarios where reduced glutathione by itself actually provides a better base to go off for glutathione synthesis, because it has less intrinsic effects and different things that it does. It's just a more straight cut way to enhancing glutathione status. So it would probably combine better with some of these other supplements that help the function and biosynthesis of glutathione.
Another question from the Optimizer was, what's the deal with NAC and histamine? Is this an actual thing? And if so, is glutathione a better option for folks who might be worried about histamine?
Yeah, this was the first time I've heard about this, but NAC indeed does seem to release histamine, and this can be a problem with higher doses of NAC. So with that in mind, I looked, does reduced glutathione do the same? And it doesn't. So if you are worried about the histamine effects, which don't really seem to be all too pronounced for most people, but for some people it seems to be much more pronounced, then reduced glutathione would be the better option.
Awesome. And finally, from the Optimizer, is glutathione likely to be easier on the digestive system? Could this be related to histamine?
Well, so I think there we have to go back to NAC and its sulfide bond breaking activity in the stomach, and maybe attaching itself to the stomach lining and then breaking some of those bonds in the mucosal lining of the stomach. And reduced glutathione doesn't appear to do this. They are both quite acidic though, so if you are just sensitive to acidity, then both will probably have the same effect. But if the sulfide bond breaking effect is where the problem lies, then reduced glutathione would not have this issue.
Amazing. Now moving on to a question from another one of our regular listeners and questioners, Hormesis. Thanks so much for your participation and your thoughtful questions. Hormesis' question is, what effect does glutathione have on the methylation cycle? Any particular benefits or pitfalls that people should be aware of?
There definitely seems to be a link here. but it might actually be working in the opposite direction. So some of the compounds that are produced during methylation cycle, homocysteine, cysteine, donor as well. So part of the output from the methylation cycle might also help enhance the synthesis of glutathione. So it might kind of be working in the opposite direction, where the methylation cycle working properly is an important factor for glutathione synthesis. That being said, it goes a little bit deeper too. So GSSG, the oxidized version of glutathione, appears to inhibit an enzyme called S-adenosylmethionine synthase. So this is the enzyme that produces S-adenosylmethionine, which is one of the most important methylation factors. So with that in mind, having enhanced levels of GSSG and having this GSSG not turning back into reduced glutathione could be something that is not good for the methylation cycle. So this is further evidence that we want to enhance the ratio between reduced glutathione and oxidized glutathione, always wanting to keep the oxidized glutathione higher than, always wanting to keep the reduced glutathione higher than the oxidized glutathione. So this is that effect of balancing the ratio, and this is where it comes into play. Another thing that seems to be a bit of a link between glutathione and the methylation cycle is that glutathione can actually protect vitamin B12, and because vitamin B12 is also a major player in the methylation cycle, this is another area where having more reduced glutathione around can then keep more vitamin B12 around, and through this action can have a beneficial effect potentially on the methylation cycle.
Wow. Very comprehensive answer. Excellent questions were asked in that category. And now we're going to move on to another really interesting category of questions that were asked on Reddit, which is questions about muscle growth. So the first question comes from the German guy 21, which is, does reduced glutathione have the effect that it reduces muscle growth the same way NAC does?
So if you, this is kind of a difficult one to answer. So taking antioxidants is definitely not good for muscle growth if you take it too close to exercise. But because taking reduced glutathione, it takes a while to build up those levels, and we're just building up reserves, and we want those reserves around. I don't think we necessarily want to apply the same logic here, because we always want to keep it around, and it's the same with NAC. Although, that being said, NAC seems to much quicker enhance glutathione synthesis and then enhance oxidative status there. So with that in mind, NAC may, due to its just rapid rise in glutathione synthesis, might not be the best thing to take right before exercise. But you could definitely take reduced glutathione at any time, because that's going to take a lot longer to enhance those glutathione levels. But with that in mind, if you do go back to our previous podcast about, actually our first podcast about tart cherry, we go quite in depth about taking antioxidants close to exercise. And indeed, the oxidative stress response that exercise produces is very critical for muscle growth. So inhibiting this process is not great. But I don't think this is necessarily a concern with increasing glutathione levels over time globally through your whole body. It just gives you more protective effects.
Cool. That's really good to know, and a great question. The German guy 21 also asks, does reduced glutathione have the same craving-reducing effects as NAC, which is similar to a question we got earlier?
Yeah, and again, I'm not entirely sure what pathway this goes through. It might be a glutamatergic thing too, in which case both NAC and reduced glutathione would have the same effect. But if it is going through the hydrogen sulfide effect, which seems a little bit more likely to me based on what it's doing in the brain, then only NAC would have that effect. But maybe both, because of its glutamatergic effect, will have that effect, but we're not entirely sure.
Cool. And then our last question about muscle growth in general comes from a user who asked a question earlier, which is TTYYLL Gabagal. And their question is, another question I have been wondering is, would NAC affect muscle growth and or muscle recovery in any meaningful way?
And the answer to that kind of goes back to what we were talking about earlier, is that when we exercise, we get a lot of oxidative stress, and then that oxidative stress helps enhance muscle growth. But then after a while, that oxidative stress then turns into muscle soreness, and we call that delayed onset muscle soreness.
Or DOMS.
DOMS, which is a very fun word to say. So taking NAC maybe like 2 hours after exercise, and then allowing those glutathione levels to build up would potentially be a good way to help enhance recovery. But I think there are some better options for that, like tart cherry has a more comprehensive effect there and has a more direct oxidation regulating effect, where N-Acetylcysteine definitely has that oxidation regulating effect, but because it's working through glutathione, which is always there, I'm not sure how impactful it will be for this specific purpose, even though it definitely will have an effect. But I'm sure other things, other oxidation regulating compounds would have a more comprehensive effect.
Awesome. That concludes the question and answer portion of today's podcast. We really went in depth talking about glutathione synthesis, glutathione processes within the body, the relationship between NAC and glutathione, and all of the different compounds, foods, and other supplements that can work really well synergistically alongside glutathione to have just this general antioxidant balancing effect in the body. So we're so glad that we got to research these topics, because sometimes with this really technical, dense information, it can be tough to start to parse out and get a general understanding of what these compounds even are, where do they come from, how are they working within our bodies, and where do they come from outside of our bodies. But today we wanted to give you a really comprehensive understanding and working theory of what is glutathione doing, why is it so important, and why might you consider supplementing glutathione in your day-to-day life and in your diet, and all the different things that glutathione is doing to help keep you moving and going in your daily life.
Yeah, and I guess my concluding remark based on that is, because we have such high concentrations of glutathione all throughout our body, and we all have it already, it's kind of one of those things that pretty much everyone could probably benefit from taking a little bit, especially the older we get, the less glutathione we have. So as we're aging, it might be an important thing to add on.
Absolutely. So that concludes the main discussion for today. We're so glad that you are enjoying and getting good information out of the In Search of Insight podcast. We release a new podcast episode every single month, and every month on Reddit, before the new podcast is released, we announce the topic and invite you to ask us questions about the topic so that you can help direct our research and we can answer your questions about compounds, supplements, science, neuroscience, and nootropics in general. We really love having this back and forth with you online, and specifically on our subreddit. That's r/Nootropics Depot. So if you have a specific question for one of us, my Reddit username is NootropicsDepotGuru and Emiel is
Pretty chill.
Exactly. So you can always tag us on Reddit and ask us a specific question, and we'll go in there and chat with you and really get into some of the nitty-gritty science and the mechanisms of the things that you're wondering about. In addition to this, we're so grateful for those of you who are subscribing and sharing this podcast with your friends. So if you know of someone who might be interested in all of this super technical knowledge, or maybe someone who's just getting into supplements or nootropics, we'd love it if you would share that with them. You can listen to this podcast on YouTube, Spotify, Apple, Google, and Soundcloud. So there's lots of different places to stream In Search of Insight. We're really excited to keep developing this podcast, for your continued participation and your listening, and to keep adding elements like the visual aids and the video and the question and answer portions so that you can be a part of In Search of Insight and understanding and enjoying all of the things that Nootropics Depot is working on for you. So with all that being said, thank you so much for listening. It's time for us to sign off, and until next month's podcast, we'll see you very soon. Bye-bye.
Bye.